Hello again. Today we're going to be covering sections 3.1 and 3.2 out of the textbook that we have available for 95-96. My name is Chris, by the way. What we're going to be covering today is some plotting points and plotting lines in two variables on a Cartesian plane. Now, what does it mean to be a Cartesian plane? Now, this might be review for a lot of you, but a Cartesian plane is something like this. Right, we got the little arrows here. It kind of looks a little bit like a cross. But what is it and what do we use it for? It turns out that this is actually a relatively new development. It was made by René Descartes, who was a French philosopher and mathematician, and he's credited for creating this system. Now, before we had a system like this, maybe some of you might play chess. And if you're familiar with chess, we know that along one dimension, we label each row or column by letters, A, B, C, D, E, F, G, H. And in the other direction, we go label up 1 through 8. What's nice about that is that and the reason why we do that is sometimes maybe you want to play chess with somebody who you can't play with right in front of them, maybe live across the country, or you might send letters back and forth. Now we're thinking old times, of course. But the problem is, it leaves a little to be desired when you've got letters instead of numbers, because what's before A? So if you count backwards, you know, A, B, C, D, E, F, G, and then you go backwards, there's nothing before A. There's no null letter. So instead of doing that, we just simply start using numbers in both directions. But that means that we need to kind of label those different directions. And what we tend to do is we tend to use these two letters to signify them. There's no particular reason besides convention. Another neat thing about this is, now these are some terms that you might have never heard before, and I thought that it was really interesting. And it kind of leads to some understanding. This is called the abscissa. Now, I believe I spelt that right. Yes, I did. And this axis here is called the ordinate. Now, you're not going to hear this from many of your instructors, but this is the way that they used to use the language. And sometimes, you know, if you're a strong language user, then maybe it might be a little bit better for you to call this the ordinate and this the abscissa. Another term that tends to come up a lot is that we'll call this what you can see in other places is the IV, or the independent variable. So I use an acronym for that. And this tends to be an independent variable because it tends to vary independently, which means that you can pick just about anything that you want, plug it in for that variable, and you'll get something on this axis. So this is kind of like an arbitrary choice along this way, and because of what we have, we'll create something the other direction. And if this is the IV down here, this particular axis, we tend to call this guy the DV, because it is dependent on the other variable. And we can see that a lot when you're familiar with something like slope-intercept form. Some of you might be familiar with this, right? That y equals mx plus b slope-intercept form. And what we use this for is because we have our IV right here and our dv right here, because we can change this in a table, for example. We can just arbitrarily pick numbers, and that number will change because of it. But if we were to try to do it the other way around, we have to do some algebra in order to solve it for the other variable. And that's why it's easier sometimes to do it this way. In a lot of the sciences that you might encounter throughout your college career, particularly in places like psychology or other social sciences, we'll have multiple independent variables that have a prediction on a dependent variable. So we know that the level of stress a student is under can help predict, to some effect, along with other variables, their test performance. So test anxiety, we know, affects test performance, as well as other things like knowledge. So we'll have like a couple IVs to one DV. So going back to just simply graphing this stuff, like I have that equation here, and I'll write it again over here, y equals 0.25x plus 9. And what we can do is, what's nice about this, like I said before, is that because we've got negatives, now we can go not only just this way, but we can go negative and positive, right? Because this is our negative and positive quadrant, right? By the way, this is quadrant 1, this is quadrant 2. This would be a negative and a negative coordinate, and then we call this quadrant 3, and then finally quadrant 4, where the x's are positive and the y's are negative. So that's something to keep in mind. So when we've got something like this going on, I'm going to go and just erase this really quick. When we have an equation, there's all sorts of ways that we can plot an equation onto a two-dimensional plane. The first way that we tend to get taught is we simply make a table, right? And what's really nice about tables is that when you have a single variable by itself, we can call this a dependent variable because it's dependent upon this. We just simply can change this one. So we can do maybe -1, 0, and 1. What's nice about independent variables is that they're arbitrary. I can pick whatever I want so long as it fits with my number system. And just kind of go for it from there. So I don't like decimals. This was 0.25. We don't tend to like that, so I'm going to go ahead and change that. Don't be so rigid that you have to keep it exactly as it is. So 0.25 is 1/4, right? 4 quarters in a dollar. And now I see, oh, wait a minute. These numbers don't really work that well for me because if I put this in there, I'm going to get a fraction, and no one likes fractions. It's okay not to like fractions, so I'm not going to use those. I'm just going to go -4, 0, and +4 now. And that's okay. Like, I hadn't even thought about that till I got to this point. You know, you don't have to have the insight to see where it's going to end up. Just keep working forward, and these things become clear. So we plug the -4 in. I have 1/4 times -4 plus 9 equals y. And I can see that so I got -4/4 plus 9. Well, they're equal but opposite, so that's a -1 plus a 9. So that means 8 equals y. And I just carry myself down one step at a time, don't do too much. So I have an 8 right there. So if I plug a 0 in, the 0 is a little easier. 0 times anything is 0. And then add 9, we have a 9. And I can start to see a trend because I know this is a linear relationship because that exponent is 1. Which means that as this goes up by 4, this goes up by 1. And this one went up by 4, so this one should also go up by 1. So that should be 10. And then we can graph it. So -4. And it looks like 8. So another thing that a lot of students don't always tend to do is they don't tend to label their hash marks. So I'm actually going to label this as -1, but I'm going to label that as 2. And just to be completely clear, I'm going to label this as +1, and this is -2 for the y. And the scales can change. You can make them whatever you want. And sometimes if you're working in my math lab or any other electronic homework submission software, you might see that they do this to you, so keep an eye on that. So -4 is over here, and I go 2, 4, 6, 8. 4 up to 8. Got a point right there. A 0 and a 9. So if that would be 8, I'm sorry, if that would be 10, that would be 8. So then my 9 would be right there. And about 4 and 10. And of course, this is the most challenging part of the whole process, drawing a straight line. And I like to start at one point and just kind of go for it and then go back the other direction there. And of course, it's not always perfect, but so be it. And these are sketches. You know, sometimes you won't have graph paper in front of you, or you won't have a straight edge to draw a nice line, but it's not always about that. So that's one way that we can plot a kind of an equation like this. Some of you are probably already thinking, well, why didn't you just use slope-intercept form? Well, I'm just trying to start from the very beginning. If you start from the slope-intercept form, we already know that our intercept was 9. And for because our slope is rise over run, that would be for every 1 up, we go right 4, and we see that right here. We go up to the 10, and we go over to the 4. And if we went down, we also go left, because a negative divided by a negative is still a positive. Let me see here. I think that's just about all I have today. So hopefully you've been enjoying these workshops that we've been providing, and hope to see you next time. Thank you very much.